Hello everyone, welcome to the webinar conducted by BCBUZZ Technologies, and I am Ram Prakash, a SOC analyst L1 trainee at BCBUZZ Technologies, and these are my LinkedIn and job profile URLs. You can check it out to know. Today we are going to explore something that sits at the heart of cybersecurity operations, network traffic analysis, or also known as NTA. Now before I define it, I want you to think about this. Every time you open Google or send WhatsApp message or watch a video in YouTube, you are generating network traffic. And here's the critical insights. No attack can happen without communication. Even the most advanced attackers must connect to a system, send commands, and retrieve data. That means even if attacker delete logs, even if they hide files, they still leave a trace in the network traffic. And that's why network traffic is one of the most reliable source of truth in cybersecurity. What is network traffic analysis? Now let's define it properly. Network traffic analysis is the process of capturing, monitoring, and analyzing network packets to understand behavior and detect threats. What is packet? A packet is a small unit of data that contains source IP, that's who is sending, a destination IP, who is receiving it, a protocol, how it is sent, and the payload, that's the actual data that is being sent. Analysts mind when looking at the traffic, you are not just reading the data, you are seeing it. Who is talking to whom, what protocol is being used, why this communication happened. That's why everything is important. For an example, DNS requests are normal, but DNS request every 2 minutes in the random domain is completely suspicious. So network traffic analysis can be used in real world to detect anomalies, investigate incidents, and understand the network behaviors. Moving to the next topic, why network traffic analysis matters. Let's go deeper into why this matters. Logs are optional, but traffics are unavoidable. Logs can be deleted, modified, and can also be disabled, but network communication must happen for an attack to succeed. It can't be completely hidden and it can't be erased as well. In in a real world example, imagine malware inside a system. Why does it need to do? It need to contact a command server, send stolen data, and receive instructions. All of this happen over the network. So if you monitor the traffic properly, you can detect attacks even if the system is compromised. So these skills of network traffic analysis are mainly used by SOC analysis in monitoring alerts, incident responders for investigate breaches, and threat hunters for proactively search for attacks. Let's break down how communication actually happens. To know how network traffic is created, we just need to learn how network works. So let's go into few network topics to understand NTA more clearly. First, how data moves. Let's break down how actually communication happens. You type a website, your system creates the packet, and packets travel through the switches, routers, ISP, backbone, and reaches the destination, and the response comes back in the same way. So the main important concept is that data does not travel as a single block. It is split into packets, routed independently, and reassembled at the destination. Think of sending a book as under separate envelopes. Each envelope takes different routes and destination. Under the destination, they all been reassembled. That's how actually the internet works. And why this matters for analysts? Because you can inspect each packet, detect anomalies in flow, identify unusual routes or behaviors. And coming to the network model, this is how basically the network works. Network model is the structure and skeleton of the network architecture. And there are two basic network models, the OSI model and the TCP model. And the OSI model actually contains of 7 different layers starting from application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. And the TCP model has 4 layers, which is combining the first 3 layers of the OSI model into one as the application layer and the last two layers in the OSI model as link layer, forming the four layers such as application, transport, internet, and link. Let's just Let me just briefly explain about each topic and we go to the next. At layer one, at the application layer, where the protocols such as HTTP, SMTP, and FTP works, where basically the data is being directly interacted with the user and the system. And at the presentation layer, the data is being modified according to using the SSL and TLS. And at the session layer, NetBIOS is being used to add the user information and other details. And at transport layer, the protocols such as TCP and UDP are used, which we will be discussing on the next slides. And all these four layers are considered to be the host layers, as these layers were are used to happen between in the system, and it does not require a network to take place. Whereas the next three layers have requires a network for happening, and those layers are known as media layers. And the first layer of the media layer is network layer, which has router in it, which is helpful in communication between multiple networks, and L3 switches are also being used in this layer. And at layer 2 is the switch and bridge, which are used to connect the systems within the network and to make communication within them. And the physical layer is the network card, or also wires that connect physically the computers and the networks, which transfers the data in the form of light, electric pulses, or radio waves. And the TCP also follows the same protocols, but it just combines few layers of the OSI model together. And this is the practical model that is being used in the current systems. Whereas OSI model is just a theoretical model, but mostly preferred for learning purposes. Moving off, Moving to next is the TCP and UDP, where TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. TCP is connection oriented, reliable, and ordered. So to get more understanding on TCP, let's just see how TCP works. First, the TCP works by connecting two systems. Like first, they sends the sync message, which stands for request for connection, and receives a sync acknowledgement from the receiver for acknowledging that the connection is being made, and the acknowledgement is again sent to the receiver, indicating that the connection has been established successfully. This is called the three-way handshake, which helps in making a reliable conversation between the senders and receiver. To understand TCP in detail, we need to understand why it is important. And TCP is important because it ensures data delivery used in secure applications, and the common TCP application that are used are HTTP, HTTPS, SSH. Moving to next is the UDP. UDP stands for User Datagram Protocol. UDP is a connectionless, faster, and not guaranteed for deliveries, which means it does not provide a three-way handshake. Just sends the data, and it does not care about whether it's being received, or it does not wait for the acknowledgement to send the next data. Example of the protocols that uses UDP are DNS, video streaming, and online gaming. On security insights, attackers often use UDP for speed or abnormal TCP behaviors. And a common example of UDP attacks are sync flat attacks and random port scanning, which uses UDP to attack the systems. Moving to next of the network basics, it's the port and protocols. Ports define which service is running where. The common ports are like 80 for HTTP, 443 for HTTPS, 53 for DNS, 22 for SSH, and 3389 for RDP. These are the common ports and the service on which the protocol has been running in the server or the system. Analysts think if you see port 433, it's an expected encrypted traffic, but large data transfer at odd hours is suspicious. And an example for red flagging is port 444, often used by malwares. And unusual ports like random ports are often the ports possible for backdoor attacks. Next topic, what you see in packet. When analyzing packet, you look at these main things such as source IP and destination IP, port numbers, protocols, flags, payloads, which is actually data. Flags, the meaning such as sync, async, fin, something like that. And repeaters, for example, you can identify the network uh, uh, traffic in such a way that repeated sync without acknowledgement is possible as scanning for an attack. This is how you can interpret the traffic that you're seeing in the network. So going into the network traffic analysis, let's just get into the idea of what do analysts actually do. So analysts actually observes the network traffics and identify the normal and abnormal behaviors. Normal behaviors are easily more understood by the analyst as it does not show any difference, whereas abnormal behaviors can be analyzed through specific rules and conditions, and it's been investigated for suspicious activities. Analysts generally answer who communicated, what happened, is it actually malicious things happened in the net, and this is the actual flow of the network traffic analysis, where the network capture the traffic, filter noise, focus on anomalies, investigate. So actually, the network traffic analyst or the person who is performing it first captures the network traffic for a specific period of time where they predict the attack would have been happened, and they filter out irrelevant data such as HARP messages, DNS queries, and the data that are irrelevant to the attack, and then they analyze the relevant packets for the possibility of attacks, and they try to detect the anomalies using which they detect what attack has been happened. Is there really any attack been happened in the system? And there are four different types of network traffic analysis. They are descriptive, diagnostic, perspective, and predictive. Descriptive analysis is basically understanding of what happened in the attacks, and diagnostic attack analysis is why did it happen. Perspective analysis of what should we do, and predictive is what makes happen in the next. These are the four different types of network traffic analysis. To give a clear idea about as a network traffic analysis, is an example of a suspicious activity. System connects to an unknown IP and uses a port 444, and it repeats the communication pattern. So this shows that this IP is not from within the network, and it's no way related to the computer system that the network is working on, and it's not using the common ports like 80 or 88 something. So it's also comes under the suspicion, and it makes a continuous communication with the system, which shows that some files are being continuously transferred between the hacker to the system, or malicious activities being done. So this possibly is a malware communication or some other attacks trying to be performed. And understanding what makes a good analyst is simply easy. Is a good analyst must understand the normal traffic, how it looks like, and what the normal traffic actually is, and they must have strong filtering skill to filter out all the regular traffic and to anomalies, and they must recognize the patterns of the common network attacks, and they must think logically to understand what might have actually happened and how it could have happened. Moving on to the tools, let's look into two tools that are very commonly used, such as TCP dump and Wireshark. TCP dump is a command line tool, which is a lightweight application that has been running on the Linux and Linux OS system, and it is mostly used in Linux servers to continuously track down the network traffics and to record it and to store them in a periodic manner. So yes, TCP dump captures the traffic directly from the interface, and it uses libraries like libpcap and commonly used in servers and SOC environments and incident responses. And why use TCP dump specifically? It works without GUI, which makes it like a perfect hacker tool, analyst tool, and it's very fast and efficient, support powerful filtering, and can serve traffic for later analysis. Here are the basic commands for TCP dump. TCP dump -e represents the port that are running on that are running currently running on the network, and -n helps in filtering out the DNS queries, and using a port number helps in filtering out only the network traffic from that 80th port, and using an IP helps in filtering out only the network traffic that are been made to this IP or received from this IP. And by using hyphen w, we can save the captured data file. Let's just work on the TCP dump hands-on. To work on it, let's just open the VMware or VirtualBox and open the Kali Linux or any other OS or Linux OS you're having. I'm using Kali Linux for this. Once the Kali Linux has been opened, just open the terminal and check is TCP dump has already been installed by checking out the version by using the command sudo TCP dump hyphen version. Here I am getting the perfect version of the Kali TCP dump that's been pre-installed in the Kali Linux. If it's not being installed, you can use the command as TCP dump su- sudo sudo apt install TCP dump. This command installs the TCP dump if it's not been installed. And let's now check what are the running connections in the application of my TCP dump hyphen D list all the running applications in mind in which each zero is currently running and it's been connected. So let me scan the each zero dump hyphen I each zero just scans all the it's now started to listen to my network traffic, and whenever I'm opening and Mozilla Firefox and trying to connect with Google. The TCP dump requests all the records all the network traffic that are happening behind the scene. And if I wanted the network traffic to be filtered specifically to a port, I can use the command like port. These filters all the ARP messages and other uh, DNS and filters out only the TCP protocols that have been registered. I'm just opening the YouTube and here I get only the TCP messages showing the acknowledgement and all the frames, flags and other things in detail. These can be analyzed manually and help in analyzing where the data from which IP to which IP data is being transferred and what are the data are being transferred in real time. And this is a command line tool, and you can just save this by using write command. There's like 80 tc4w some file name file.pcap. This pcap extension is used to save the network traffic that are being recorded by the TCP dump. And this writes down all the files in the file.pcap, and we can open the pcap file to look into the network traffic that is being stored. Moving on next, let's look look into Wireshark. Wireshark is used for deep packet analysis, whereas TCP term records all the network traffic that are being stored. Wireshark performs a deep packet analysis on it. It's a GUI based network analyzer. It supports different protocols, plugins, and there are different statistics that are pre-built and pre-analyzed by the Wireshark. It's used for traffic inspection, incident investigation, and troubleshooting. And the network interface of the Wireshark by default shows the packet list, packet details, and packet bytes, which are summary of the packets, protocols, breakdown, and raw data. Let's just first know how to install Wireshark in the Windows. You can visit the website of the Wireshark and download it according to the Windows or Mac systems are using, or if you are having Linux, it's been pre-installed in your systems. Just open the Linux and search for Wireshark. And this is the Wireshark application. And by default, as my 80 port is running, I'm using it. And once I try to ping on the let me just ping on to the Google website. Once the Google website get started to get pinged, I'm able to see the network traffic has been captured in real time and been analyzed in the Wireshark. So first let's get into the interface and let's go deep into it. Let me just stop it. And to understand, these are the network traffics that is being recorded and been analyzed, and each of the color is being used for different protocols, and these it can be edited by selecting the color rules, and each color is used for different protocols and which can be easily edited. And here is the important part. This is an example of a DNS system where we can see clearly the level, so different levels of the packet. At the level 1, we are able to see the frames, and at level 2 we are able to see the Ethernet packets, and where the level 3 we are able to see the IP packets, and At level 4, it's the application, which in a network terms, this level, the data in these levels are known as bits. In this, it's known as segments. In this, it's known as packets, and here it is known as the data. And we can clearly see what's inside each of this packet. Like in frame one, it's the frame details will be there. It gets interesting when we open the IP packet. Here we can easily see the source IP, destination IP, and other things. And on opening the domain name system and queries, we can easily see to which system it actually sends the query. And it is sent to Google. And while opening on the next packets, are able to see to which the packets are being forwarded in real time. And once it reaches the DNS of Google 888, it's just starts to sense back. And by opening on this, we are able to get the answer from where the DNS is being received with the IP of the google.com. IPv6 address we have got. This is the IP of the Google that we have been trying to ping down. Let's just try to recapture it in a Chrome or Edge. Let's just stop and try to recapture it. Once enough data has been captured, we can just stop it and let's just try to analyze the basic things like how the TCP connection is being made. So we can just filter out only the TCP commands that are being sent, and these are all the TCP packets that are the sent through TCP protocol. And here we are able to clearly see the sync and acknowledgement sync with acknowledgement and acknowledgement for the above request, which shows the three-way handshake protocols clearly in network traffic. If you see the sender who is it's me sends the sync message to the destination server, and I got the response from with acknowledgement. And for making connection, I just received from acknowledgement, and I'm sending back the acknowledgement to them. This is how the three-way handshake works. Each time you click on a website, and each time these data are being recorded, and this packet can be clearly seen by double clicking it. On opening on the TCP, the flag shows sync acknowledgement and the binary digit of it, and it's used to understand if something has failed in between, and if connection establishment is not been done, it can be used. And similarly, we can filter by using the IP address. Like if I want to filter out only the network traffic made by the IP address, I can just apply as filter selected, which brings me only the uh, network traffic that is being sent from my IP address to all the other IP addresses. And most of it are to Google, as I have just opened it. And if there are multiple websites being opened, there will be multiple destination IP addresses as well. Now let's just use the statistics to pinpoint the conversations. And as I said, I just made a connection with 888, and three packets have been sent, and those three packets were used to redirect me to the Google website. And these statistics helps in getting a clear idea of the total package sent, stream IDs, and other details. And the filters can also be applied directly from here by apply as filter selector, and these are used to sort out different filters. Like if I wanted to select any packets that are received to me, I can use it, which makes me as a receiver IP, and I can sort out different sources from which I have received the packets from. And you can you can directly capture only the TCP or other packets over while being capturing it as well. By filtering this, now the Wireshark captures only the TCP packets directly. These are now the Wireshark is capturing only the TCP packets from the internet, and all other packets are not being captured. And this can be used in specific conditions. Now let's just so in real world traffic analysis how Wiresharks are being used. In real world, the Wireshark is used for traffic analysis as SOC detects suspicious activity. They just report the network traffic, and the network analyst just look into the network traffic and identifies the port and other details. Here's a simple example where a SOC detects a suspicious activity and an alert has been raised, and the goal is to identify the infected machine. And these following details must be identified from the network traffic that we have got from the SOC team. And there's a website known as malware traffic analysis where there's multiple PCAP files that are made that are collected during different attacks, which are used for education purpose. I have downloaded this file, and I have unzipped it. Now I'm just going to open it by clicking files and open. And this is the file that I just downloaded. And uh, as mentioned in the website, there is the SOC has identified attack from this IP, and the network traffic is sent to us for analysis. And these are the details about the user network. And our task was to identify what is the IP address of the infected Windows client, what is the MAC address of the infected Windows client, and what is the host name of the infected Windows client, and what's the user account name of the infected Windows client, and what is the full name of the user account. And there will be answers provided in here also, and it's completely free. You can check it out as well. And I'm just opening the file. This is the previous filter that we have applied, and this is the network traffic file that we have got from the SOC that SOC team will provide us. And we have to identify the uh, infected client's IP first. That can be done by simply filtering out all the systems that are made communication with the malicious IP. That's like by copying this. and we can filter it out by IP dot destination. By doing this, we are able to find that the infected IP is 10.2.28.88, as most all the conversation are done with this IP only. And we can also check where any traffic been sent by using the source. And it also confirms that there has been continuous conversation between these two IPs, which confirms that 10.2.28.88 is the infected IP, which shows us that we have identified the infected Windows client. Now we just have to identify the MAC address of the infected Windows, which is simple. By double clicking on the infected IP, we are able to see the network packets, and on opening the Ethernet, which Ethernet packet is shows the source MAC address. Then this is the MAC address of the infected IP, and next the host name of the infected Windows client. And this can be identified by using the NetBIOS, which we have seen, which is an protocol used in the layer 2 of the OSI model. We can just type in BNS, which stands for NetBIOS, and NetBIOS name services. And by filtering out, we are able to see our IP, and on by further inspection, and it confirms that the name is EASY, and this is the name of the. And next, we have to find the account name of the infected system, which can be identified by the protocol of Kerberos. And by typing K or Kerberos, we are able to filter out only the Kerberos packets. On opening the Kerberos packet and Kerberos pack, and here is the username of the infected system, and we can just apply a set filter to short only the Kerberos infected users. And this is how we can find the username, and next to be found is full name of the user from the user account, which can be easily found by going to a direct find packet option. And I'm just entering a string, so I'm just selecting a string, and I just know the name of the person as Brawl, so I'm just typing it. I'm just finding it, and if I go through all the packets, I am sure I will be able to get the full name of the user. This is the this is the Cabos packet that we have opened already. And by analyzing this packets, will be able to identify the full name of the user. And this takes time. We're just going to the next options. And this is how the Wireshark can be used in real-time network analysis. And this site has few more activities as well, like different tech events like warm cookies and fine fish in little pond, which are different traffic analysis exercises which can be used to learn and get hands-on experience on network traffic analysis. And we have completed all the investigation objectives and we have found it as well. And you can visit learn.bcbuzz.io website to get free courses on different cyber topics, and different webinars are also available in that site. And you can message to this to get more details about the BCBUZZ technologies. Thank you.